Kia ora, year 12 and 13. This is a short video, on polynomial long division. This is a technique that comes in handy in some strange places. So I'm going to do a video looking at how we do the long division first, before I start talking about where it comes in useful. And people who went to school 30 years ago learnt how to do long division really early on. So we learned how to do problems like this, 539 divided by 12, where you guys learnt strategies so that you could do them in your head, and then you moved on to calculators. We learned how to do them like this. So we'd do 12 into 539, 12 watts go into the first two digits there, 53. So 12 fours are 48. So I would take 48 from 53, get 5, I'd bring down the 9. 12 watts go into 59, well it's 4 again, so it's 12 fours of 48, and then I have a remainder of 11. So we would write 539 equals 12 times 11, 12 times 44 plus 11 remainder, or something like that. Right, so more obviously, if we have a really little number like 53, we can write that as the product of two numbers plus a leftover. And we can do that for whatever factor we pick. So if we want to look at how 10 goes into 53, we'd write 5 lots of 10 plus 3 left over. What we're going to do today is extend that idea for polynomials, and it's surprisingly easy once you get the hang of it. So let's start with a quadratic that we know. So this one I'll work up. So suppose we've got x plus 5 times x minus 7. Well, we know that that's x squared minus 2x minus 35. Right, now I'm just going to take 3 more off that. Okay, so but we know that that's a factorised polynomial. So suppose for some odd reason I want to know what happens if I've got x squared minus 2x minus 38, and I want to divide that by x plus 5. So how do I do that? Well, we know because we've already factorised that it's going to be this thing up here less 3. But I'm going to show you a method to figure that out. So we start with the same division thing that we had before. In here we put our polynomial, right, and our notation is going to be that we call that p of x. We want to divide it by x plus 5, so we write that out here. Now we just do a matching up process. We say, well, x times what will get me x squared? Just look at that, the term, the first one that I'm trying to match. So that will be x times x squared. I write the x up here in the same way that I did in the first long division. So I match it so it lines up with the x column. Right, x times x is x squared. X times 5 is plus 5x. Now I subtract that one, and I get minus 2x minus 5x. So notice what's happened here is I've deliberately done it so that I get x squared minus x squared. So this term should always be 0. If that's not happening, you've mucked up. Go back and fix it. Now I've got minus 7x, and I'm going to bring down the minus 38. So I look at my minus 7x, do that with a different colour, and I say what times x will get me that? Right, let's get rid of that mess. X times negative 7. So negative 7x minus 35. Okay, so here I have 0. I'm subtracting all of that. So I have negative 38 plus 35 is minus 3. So what I've got here is that I've written, oh, now I've run out of room. Let me just see if I can squeeze it in. So we've got x squared minus 2x minus 38 is equal to x plus 5 times x minus 7 minus 3, right? Which is what we knew we'd get because we'd kind of pre-baked that one. Okay, now we're going to try it on a cubic where we won't know what we're going to get first. Okay, so let's do write x cubed minus 7x squared minus 5x plus 56 in the form px equals x minus a qx plus r, where a equals 4. Now that looks much more formal and a bit intimidating, but all it's telling me to do is to take this polynomial, which is p of x, and divide it by x minus 4. Right? Now if you're thinking ahead, obviously if we end up getting a remainder of 0 here, then we have factorised, or we have at least started to factorise that cubic polynomial. So that should give you a clue about where this is going to come in useful. Right? But first we'll just do the mechanical stuff. Now I want you to have a go at doing that now. So I'm going to put a new slide in. If you can pause the video and try it, that would be good. Okay, so, whoops, going a bit wonky there. X cubed minus 7x squared minus 5x plus 36. And here I've got x minus 4. So I do my match up. I'm going to do this one a little bit faster. So x times what will give me x cubed? X squared. X cubed minus 4x squared, right? Whack in your brackets if you need them. So that's 0 minus 7x squared plus 4 is minus 3x squared. Bring down the negative 5, minus 5x times negative 3x squared plus 12x. Right, put in your subtraction sign. 0 minus 5 minus 12 minus 17x plus 36, right, x times negative 17, negative 17x plus 17 fours is 68. Right, so then we've got 0 plus 36 minus 68 gives me minus 32. Now, I just want to say that you usually when you do this, you don't write these zeros. Right, I'm doing that just because it's the very first few examples you've done. So then, we've got our answer. We have got x cubed minus 7x squared minus 5x plus 36 equals x minus 4 into x squared minus 3x minus 17 minus 32. So p of x is that bit there. This is x minus a, this is q of x, and this is r. Alright, just trying to think if I had another one I wanted you to do, but no, I think that's all for now. You can practice these yourself by just making up polynomials. Okay, and if you want to do ones where you come out with a remainder of 0, just start in factorised form, expand it, and then practice getting it back. Okay, and we'll use this technique a little bit with complex numbers problems and also with factorising higher level polynomials. Thanks for watching.